Number 5. Find the average rate of change. Okay, so timeout. We're not even using calculus right now, right? We're actually doing pre-calc because if it's at instantaneous rate of change, then we would be using what we know about calculus. But the average rate of change now is just basically looking for the secant line that passes in this interval. Okay, so we're going to do a couple things here. First of all, we know that the average rate of change, the AROC, equals the slope. Okay, it's the slope, and so what we would just do is figure out what f of 4 is minus f of 2 divided by 4 minus 2. That's it. So we just got to figure out what f of 4 is, and f of 4 is, we're going to plug that guy in. Okay, I'm going to do this by hand, and then we're going to do this f of 2. Okay, and we know that's going to be all over 2. There we go, put 2 big brackets over there, and then we can do this without using up any space. Okay, so now we've got 16 times 3. 16 times 3 is 48. 48 minus 20 is 28. It's 29. 29 minus 12 minus 10 is 2 plus 3 plus 1. Nope, I'm messing up here. That's going to be 412 minus 10 is, oh wait, I don't know what I did the plus 1 for. Minus 10 is 3, so minus 3 divided by 2. Okay, so let me make sure that I'm not botching this up. So 29 divided by 3 is, 26 divided by 2, 13. Okay, alright, final answer. Alright, okay, so let's see. The graph below shows f of x, determine whether the slope of the function to the line at each of these points tendency will be positive, negative, 0, or undefined. Okay, now, right now, just looking at it, I don't have any issues with undefined. I don't see any kind of points or any tangent lines that they're going to go vertical, or if there's a sharp point. So I don't have to worry about that, okay? I don't have to worry about this does not exist at all, okay? So where x equals negative 1/2, we are right here, and so we would say that the slope right there is negative, yes? At x equals negative 2, right here, we would say that that would definitely be positive. Remember what I'm doing, I'm just looking at a tangent line. At x equals positive 2, that also is a positive slope. And at x equals 1, that looks like a 0 slope. Okay, that's all. Identify any values of x of anywhere the function of the graph is non-differentiable. Well, I just kind of talked about that right here. We would say at x equals 3, the limit of the limit of the derivative of f of x as we approach x from 3 to the left does not equal the limit as x approaches 3 from the right of the derivative of f of x. Okay, so it is undifferentiable. Okay, because this guy wants to go positive, this guy's going negative, and so those two limits do not match each other. That causes the sharp point. So there we go. Okay, so we want the third derivative of this guy, so let's do the first. So that'll be 18x to the second minus 8x plus 5, no problem. Y double prime would be then 36x minus 8. Alright, and then that's it. So third derivative. Okay, third derivative is 36. Alright, there we go. Fourth derivative of this, I feel like we might have done this, or was it cosine? I can't remember. But we'll just go y prime is going to be cosine. Y double prime is negative sine. Y triple prime would be negative cosine. And then y4 would be then positive sign. So it looks like it's just positive sign of x. Alright, 10. We're going to split this x to the negative 1/2. We're going to give it to each one of those terms. Alright, so we're going to go ahead. You could use the quotient rule, but I think it's actually a little easier to do it this way. So that we're going to get x to the 3.5, which would be 3.5 is 7/2, right? Because that would be 8. Okay, so that's 7/2 minus 3x to the 2 minus 1/2 is 3.5. That will, did I do that right? 4/2, right? So that's 8/2 minus 1/2 is 7/2, and then that would be 4/2 minus, it'd be 1.5. Alright, so I don't know what I was thinking. Then we got plus 6x negative 1/2. Okay. So remember, he drops a 1/2 degree, he drops a 1/2 degree, and then he will drop a 1/2 degree, but because he had 0, he was just going to have negative 1/2. Okay. So now we're going to just do what we would normally do, and now we're going to drop a full degree, so that this becomes 5/2. Okay, this will become minus 9/2, because 3/2 times negative 3 is negative 9/2. Then he will drop a full degree, so he'll be 1/2. And then this will become negative 3, and then he will drop a full degree for a minus 3/2. Alright, and that is perfectly fine answer right there. And let me just double check, make sure that, yep, okay, that's good. Okay, perfectly fine, no need to rewrite it, don't worry. Alright, now this one you cannot escape the product rule. You have to use the product rule here, and I see one function here and one function there. This will be my f, that will be my g. And so I will do this guy, take the derivative of the first, but not the second. And then I will take plus not the derivative of the first, but the derivative of the second. Okay, just look out for anything that I can do to combine. There's nothing. Obi, what was that? There's nothing out there. These guys could have been switched. Their order doesn't matter. There's nothing we can simplify, and factoring out would be pointless. So, perfectly fine answer. Alright, here's another one. This one, we are stuck with the quotient rule unless you know some kind of magical trig identity. So what we're going to do is we're going to assign this guy's the f, that will be the g, and then we're going to use the quotient rule, and the quotient rule says that we take the derivative of the first, which is secant tangent, multiplied to sine x minus 1, minus, do not take the derivative of the first, but the derivative of the second, which is just cosine, all over sine x minus 1, and we're going to square that. Okay, now secant times cosine. Secant is 1 over cosine, so these guys are reciprocals of each other. So this is 1. This guy's going to just become 1. Alright, so I wonder if this becomes sine. Let's see. Secant times tangent. Let's see. What is that? Secant times tangent is 1 over cosine, and then that's sine over cosine, so that'd be cosine squared. So, sine. This is, I don't know if this is going to be particularly pretty here. Looking at the answer, and there is, oh yeah, there's nothing you can do. It's not pretty at all. This is actually your final answer. This is the only thing you can reduce. These guys are perfectly fine there. You can't even take one of those out because he does not have a sine x minus 1. So this guy's done. So that's nice. Differentiate, we're going to rewrite these guys. I'm at 10 minutes. I'll stop right here and I'll do these in the next one.